All right, everyone, welcome to August. It's really great to be here. I hope no one drowned in the rain. Eric, you surviving? Not Eric, sorry, Subik, where are you? You good? You survived, okay, yeah. You came in the wettest of all, so I hope you're doing well. All right, very first thing we always do, and hopefully get a better response this time, who's hiring? Oh.
So.
Wait, are you hiring?
So we were.
They're not on camera.
Sorry, we were talking about some modeling stuff at Posit, and we realized we don't have anybody who's like a Python data analysis person. So if you have any, so in Q4 we'll have it's not open now. So if you go to careers, you won't see it, but we're going to have a position open in our group, but it's not like Tidymodels stuff. It's like how can we make Python modeling, especially interactive data analysis parts of like data analysis parts, better. So that's something we'll be doing in October.
Have you spoke with Wes?
What's that?
Have you asked Wes to help?
No. Actually, this is something me and somebody else came up with, and it just worked. So it's great. Yeah.
All right.
Don't look at that as
it's an omen.
An omen for what I just said.
For those of you watching at home, it sounds like a building just got struck by lightning or something. All right, so if you're not watching at home and you want to hire someone from this group, and there's 15,000 members in this group, there's a lot of people to hire, I want you to go to nyhackr.org and click on the link for the Slack. And once you join the Slack, there's a channel called Job Postings, and you should post your job there. We have a few postings every now and then. Post it on there. Maybe you get someone from this group to apply for your job. So if you're looking for jobs, go to that. If you're hiring, go to that. Next up, clearly more important than jobs, the pizza this month is from Artistic Pizza. So some of you already know what to do. Everyone is new. Everyone's not new. Pull out your phones. Pull out your phones and go to bit.ly/pizzapoll and vote on the pizza on the 5-point scale. This is a very scientific data set we've been collecting for about 12, 13 years now, with a hiatus during the pandemic. But let us know how the pizza is, because we have a live feed of the data. We have a beautiful bar chart, and people have announced this for a Tidy Tuesday one time. They did all sorts of analysis on this. It was really fun. So go check that out. If you're watching from home, let us know what you're eating in the comments section. Vikram, I know you're somewhere watching. Let us know what you're eating. Anyone else who wants to contribute, tell us wherever you are around the world. There's two ways to actually be in touch with us through the comments. You can either comment directly on YouTube, or you can comment at nyhackr Slack. There we have a channel called the Monthly Meetup Chat. Go there and be a part of it. Let us know what you're eating. Let us know how it stacks up to this great New York City pizza. All right, so everyone's voting. I appreciate everyone's time and effort for that, so thank you very much. All right, next up, we are just a week and a half away from the New York Data Science and AI Conference. Yeah, thank you. Thank you very much. We're very excited for this. This for a long time, we had the New York R conference, and we recently made it the Data Science and AI conference too. It's always been a big tent. We really want to make it clear that it is this big tent. It's always been R and Friends, but now it's definitely R and Friends and AI and Python and SQL and Go and Gen AI and LLMs, whatever you want it to be. All right, so it's a really great event. It's August 25th through 27th. The first day is workshops. The next 2 days are the conference itself, all the talks. If you want to learn more, go to dataconf.ai. And you can also learn more through our Twitter handle, which is theDataConf, or Blue Sky, which is the website dataconf.ai. And you can also find us on the Lander Analytics LinkedIn page, and we have information for you there. Many, many ways to find out. Or you can just message me, and I'll tell you all about it. Come up to me in person here, I'll tell you all about it. If you're a member of this group, and if you're in this room, you're watching at home, you're a member of this group, you can use code nyhackr for 20% off tickets. So everyone in this room, everyone watching, 20% off tickets with code nyhackr. After the talk, before the Q&A, we need to remember to do it before the Q&A, we're going to give away a few tickets. We're going to give away one in-person ticket, one virtual ticket, and we're going to give away, how many are we giving away? 4, wow, 4 tickets to the machine learning workshop taught by Max Kuhn.
Give them away before the talk.
Before the talk.
So they'll be like, you know, I don't need it.
Yeah, Tidymodels. Let's go do scikit-learn.
Yeah. Wait, what?
Where's Andreas? So, but seriously, it's going to be fun. If you've never taken a workshop by Max, it's really awesome. He's really fun. So you'll want to win these tickets. It's going to be awesome. And anyone who wants to volunteer, we're looking for a few more volunteers to help out with the conference the day of. It mostly consists of handing out swag to people, moving some heavy boxes, getting yelled at by Nicole. No, she doesn't yell. She's very nice. And then, of course, you do get to watch the conference. We want to make sure anyone helping out gets time to watch the conference. But it's going to be a lot of handing out things, maybe handing out bottles of water, swag, different things, moving things around, helping with signage, helping direct people. So if you want to volunteer and you're in the room, go see Nicole after the talk. If you're virtual, message Nicole either on our Slack or email her, contact us on LinkedIn or Twitter, anywhere, all the different ways you can get in touch with us, but just let us know. Then, relatedly, that's a good word. All right, related to this, October 25th through 27th, we have the Data Science and AI in Government Conference. That's going to take place at Georgetown, down in DC. I think I said October 25th through 27th. Same thing, dataconf.ai/gov. What did I say? What did I say? It's October 27th through 29th. Thank you, in case I got that wrong. 27th through 29th at Georgetown. Same website. We'll be announcing details in a few days, actually. It's going to be the similar idea to the New York conference, but it's going to be government focused. That could be federal, state, local. It could be NGOs. It could be international governments. We always have like an odd talker here. Not odd's the wrong word, but a talker here and there from the Canadian Police Department or from the Netherlands or from all over. We have people who make FDA submissions who work in industry but submit to the FDA. So that'll be a really fun conference, very similar vibe, though less alcohol because it's at university. So, do as you have to do. All right. For the meetup, we need speakers for September and October. I see some of you looking away, right? Some of you owe me talks. Some of you don't know that you owe me talks, right? I will call out people randomly if I have to. I've done it before, right? The two of you. Who here wants to give a talk? One of you has to raise your hand or we can't leave. Oh. You. All right. And someone, you owe me one. It's been a few years, hasn't it? Yeah. All right, there we go. October is, all right, since that'll be a lead into our government conference. All right, Subik's doing October. Who else? We need September.
You want MCP?
MCP in September? All right, Frank. All right, look at that. Look how easy this is. Just like the old days. All right, last thing before we get to our illustrious speaker. Pausing for the thunder. That's a great intro for you. I love this. It's like the count on Sesame Street. Every time it says a number, it storms. All right. The bar. We're going to the bar. Who is going to come to the bar with us?
Yes.
Raise your hand if you're coming to the bar. We need a head count. Wow, almost no one? All right, cool. That's not as many as usual. All right. Well, yeah, we just walk in. All right. We will tell you the name of the bar afterwards. I feel like if we don't want to waffle, it's probably going to be White Oak Tavern because we love Malt House, but we're all going to drown. So we'll probably just do White Oak Tavern and we can just walk in there. But you got a rough sense, Nicole? You got a rough sense of how many people? All right, cool. So we'll go to White Oak Tavern after the talk. So anyone watching virtually who wants to join us, that happens, come to White Oak Tavern. Anyone in this room, we'll all head over there. You can't miss it. It's like one block that way. All right, if you can miss it, use Google Maps. It's real easy. All right, with that, we have someone who's been using R for so long, he used it back when it was called S. Right?
Yeah, I'm old, Jared, I know.
That's more of a reference on your open source bona fides, right?
True.
You and David Smith using S since back in the day. So everyone, please give a really warm applause for a repeat speaker, longtime member of this community, Max.
Thanks for coming, braving the weather. I was thinking about, he asked me for a talk. I'm like, we have a lot going on, as you'll see, with Tidymodels. And I realized, I look back, I think I was the second speaker after D-Rob after the pandemic. So it's been like 3 years. So it's been, Jesus. So anyway, so there's things I've talked about at the conference, which I won't rehash here, but we've been in a huge development spurt. So it's going to be a lot of stuff. Here where the slides are, if you go to GitHub, Topepo, and you'll see it is the first repo for now. There's a lot of links. So this is just like an introduction to some things, and you can get a lot more detail for other presentations and things like that. Just remember Topepo, and you can get there. And then, this is not a me thing. It's the Tidymodels team. So there's me and Hannah is up on the top row, and then below in front of the foliage is Emil Hitveld. who does a lot. He just posted something kind of amazing with Quarto today, so he does a lot with that. And then in front of the tent is Simon Couch. Simon was a former intern with us early on, and actually he won the Chambers Award for the art package he made for that. Simon is going to be moving on to AI stuff within the company. So he's been doing, if you follow any of this stuff, some really amazing substantive like AI R packages. And so they're going crazy with that stuff in the company. So, so really there's going to be the three of us in a few months. We also have, I don't have a picture over here, but I'll mention her again. We usually have summer interns. So Frances Lynn is our summer intern working with us for another 3 weeks, I think. So there's a bunch of packages. There's like 2 or 3 of them that aren't on CRAN yet. Tidymodels, I'll talk about desirability functions. That's something that's, the package has been around for a while, and in fact I wrote desirability and then did the second one for reasons. But I'll show some recent things we did with that. Filtro is some supervised feature selection stuff that Frances is working on for her internship. Has anybody here heard of mirai? Okay, I'll introduce you to that. Or the future package. Has anybody ever heard of the future package? Yeah, okay. Tailor is something I sent to CRAN like 3 days before their holiday, and I haven't heard anything back, so hopefully I'll hear about that like on the 20th maybe. Bonsai, and another one that's not on CRAN that will be soon, hopefully, called important, because we like naming things in the most grammatically complicated way. So when you talk about the important package, it just gets confusing. I have a package called probably, and spell check hates me. Like I'm ruining AI for grammar. So anyway, I will say that a lot of this stuff is still in active development. Specifically, we've rewritten a lot of what happens in the tune package for good reasons. And then also workflows. So those two are still, like as soon as the CRAN holiday is over, we're hoping to send them in. But they're very much been refactored and improved. So if you see something here that's interesting, maybe give it like a couple weeks or give it a shot. And if it doesn't work out, send me a message and I'll just tell you what branch you should be using from GitHub. Okay. I wanted to make some example data. We have some simulation functions in one of our packages. Sim classification does something I made in caret, this like simulation, sort of like a complicated logistic regression model. So I simulated 100 or 1,000 samples. This intercept minus 12 here, what I wanted to do is use a class imbalance as an example of some features that we have. So when you do this, out of the 1,000 samples, about 11% of them are one class, and then the other class is the majority. So it's not a huge class imbalance, but this will come into play with some stuff I want to show off. And so we have this data frame that has 1,000 in it. If you use Tidymodels, you can see we do our training and test split. We do it stratified on the outcome to preserve the frequency. We get the training data frame, and then we make some tenfold cross-validation folds that we'll use for resampling. The links are down here in this cranberry color. So if you want to see exactly what kind of a system this is, you can get the slides and take a look. So the example I'm going to use is a cost-sensitive neural network. We have this package called Brule, which is our wrappers around Torch for like things like logistic regression and neural networks and things like that. It was basically me testing out how Torch works. But you can do a lot of things with neural networks, especially that you can't do with other packages, at least R-based packages. Like we have cost-sensitive learning built in. We have all sorts of like different stochastic gradient optimizations and whatnot. So it was like me able to fill out a bunch of things that aren't in any R neural network packages. So anyway, I'm going to fit this fairly complicated neural network you see here. I hard-coded all these parameters because I didn't want to make a big plot of all the tuning parameters. But the thing I am going to do is I'm going to try to optimize the class weights. So what you can do with some types of models is you can say, well, my minority class of 11% event ones are important to me. Let's say their customers are going to spend a lot of money, or they're adverse events in a pharma trial or something like that. I want to make sure that the predictions on those is pretty good. In fact, I want to make really sure that when I call something an event, it actually is an event. So when we think about classification models, we think about getting class probability predictions. And when you have like a big class imbalance, what you typically see is like the minority class ends up having probabilities that are very close to 0. So sometimes like a 50% event rate doesn't really tell you much because your sensitivity is 0 and your specificity is like 100%. So when you do like this class weighting, what you do is you encourage the objective function by the neural network, which in this case is cross entropy. You can say, well, when you compute cross entropy for the minority class, give it like 3 or 4 or 5 or whatever fold increase in importance in that calculation. And what that will do is that'll change the model and have larger probability estimates for the minority class. So this model will still use like a 50% cutoff to say event, non-event, but the difference is we're using this tuning parameter to sort of coerce the model to have higher probabilities for the minority class. But we don't know what that number should be, so that's why we tag it here with this value of tune, and then we'll do like a grid search to figure that out. I should also say that there's maybe 6 different things I'm going to talk about with Tidymodels, and their context switching is like pretty severe. So if you see anything you have questions about, raise your hand, because I would rather talk about them at the time. Okay, go ahead.
I have a question. What is the difference between these class weights and upsampling?
Oh, that's a great question. So what's the difference between class weights and upsampling? Not much. So the class weighting is basically takes the variable that is the actual outcome and sets weights accordingly. You could just as well have a dplyr mutate that says if class equal class 1, then weight equal 3, and so on. So there's not much of a difference in doing that. There's probably like you can have fractional weights with things like case weights, and I don't know how well you can do that here. But the class weighting, since we have 2 classes, is pretty simple. But if you had 3 or 4 or 5, you can actually have a whole cost structure, which is I'm not sure how you would do that with case weights. Yeah, good question. Okay, so we're going to tune this. It's a neural network. We want to make sure everything's on the same scale. So we'll just do a little recipe and just center and scale all our predictors, and then put that together in a workflow. And historically, a workflow is a combination of a preprocessor, like a formula or a recipe, along with a model. So if you have a bunch of different models and a bunch of different preprocessors, instead of you having all these combinations in your workspace, you can just bind them together with a workflow, and then you get one liner for fit and predict instead of doing things manually. So that's what a workflow is if you've never seen it. Think of it like if you use scikit-learn like a pipeline. That was originally my name for it, but somebody was like, oh, we don't want to confuse that with like a dplyr pipeline. I'm like, okay. So we called it a workflow, which is better than many of the names I came up with. So anyway, so right there is the specification. The only thing we don't know is what the class weight should be. And so what we're going to do is we're going to do a little grid search. We're going to look at weights going from 1, which means no differential weighting, to 50, which means the minority class has 55 or 50 times more important influence on our objective function than the majority class. And then we're going to compute Breyer, score, kappa, sensitivity, and specificity. Now, these 3 at the end here are dependent on the hard class predictions, like is it class 1 or class 2. And then the Breyer score is, anybody ever heard of that or used it? It's kind of old school, and I heard people talking about it for a while, and I looked at the formula for it. I'm like, what's the big deal? I'm convinced this is a thing we should be using. It's basically like RMSE, but for classification. It's literally measuring how far your prediction is from the truth. So if you think about having 0 and 1s for your outcome, it's basically doing a sum of squared errors. And it has a lot of nice theoretical properties. And for the most part, it tends to capture how well calibrated your predictions are. So you could have a high RC score, which means you can differentiate your events versus non-events, but that doesn't mean the probabilities are accurate. And if you have a very well-calibrated model, your Breyer score will be close to 0, and it should be also separating. So for me, it's a much, much better situation. A lot of neural networks or anything that use like a softmax transformation tends to give you not always poorly calibrated predictions, but you'll know that with the Breyer score. But I just want to use that as an example of things that affect hard class predictions and things that affect the probability estimates. Okay, so we're doing 10-fold cross-validation. We're going to try 50 values, so we're going to end up fitting 50 models here. It's not new, but I thought I would mention, for a long time, I've been really big on these things called space-filling designs, which are from the statistical experimental design literature. And the basic way of doing that is something called Latin square, which a basic Latin square, it fulfills the goal of a space-filling design, but it's maybe not as good as it could be. And I found a lot of people who have optimized various other space-filling designs to be non-random, and they just put all their designs online. So I just sucked all those up and put them in a package. And so now it's a little bit different how we do our tuning parameter grids. They're based on these non-random space filling designs, which are excellent. So that's a difference maybe from last time I was here. Okay, so we run our grid search, and if we just want to see how the Breyer score changes from as we look at the minority weights, you can see it's lowest when you consider them equal, and this makes a lot of sense. The problem with class imbalances is we want to get the minority class predicted well, but if you make their probabilities higher, you're actually discalibrating your model because your model is not consistent with what the data is in the wild. So we sometimes have to sacrifice calibration to get better predictions from our minority class. And that's kind of shown here, that usually with two classes, you think of a Breyer score around 0.25 as being not great. So we're not quite there yet, but we can see that we're sacrificing some calibration as we increase the minority weight. The kappa statistic is one that is like accuracy, but it's normalized for the base prevalence. So you can think of like if I have a 90% majority class, think of like accuracy divided by 90%. So if my accuracy is 90%, like kappa, 1 minus 0.9 in the bottom, kappa would give you like a 0 value. So it normalizes and standardizes for your the event rate in the wild. So 0 is bad. You know, anything from like 0.6 and above is pretty good. So again, since it's best here at the equal odds, just because of the way the frequencies work. Now, when we look at sensitivity and specificity, we see what we might expect. Specificity decreases as we give the other class more emphasis in the calculations, and you can see the sensitivity goes up. And depending on our situation, we might want to say like, well, I really want to optimize for sensitivity. Like if I'm doing like testing blood for like, you know, bloodborne pathogens, you want your sensitivity is very high. You don't mind throwing out 100 liters of good blood to get 1 bad liter of blood out. So, you know, depending on your situation, you would figure out how you want to optimize these two things and choose your minority weight class appropriately. But you can see this sort of trade-off here. So that's doing what we want. You've been able to do all this stuff in a while in Tidymodels. So after this is where really the new stuff starts. Any other questions? Cool. All right, so new things. First is parallel processing. Good and bad news. I mean, the bad news is we're kind of sad because we've been using the for each package for a while. For each was developed by a friend of ours who passed away a few years ago. His company got sold to Microsoft and they've maintained it, but it's not really being actively developed. And so because of that, we decided to move on and use, initially we thought we'd use the future package. And future is being very actively developed. It's very good. We like it a lot. So if you were using for each before, you would load something like the do parallel package and you create like a cluster object. Here's the important part. You register with for each that you are doing parallel processing with this cluster object, and it can be like on your computer, it can be across like an HPC grid or somewhere else. For each can do all sorts of like ways of targeting different computers. And then when you're done doing your calculations, you just shut down the cluster and everything's fine. Future is a lot simpler. You just load the future package, and a plan is how you want to parallel process. So multi-core would be like doing forking. Multi-session is like PSUC clusters, which is most parallel processing in R, and so on. And then you can tell how many cores to use, and then just do your thing, and then you're done. And Future works great. But in the meantime, last year around now, I met this guy who wrote the mirai package. And mirai is a whole new framework for parallel processing. You can use it with futures and with for each, but it's a sort of an independent implementation from the ground up. And the guy actually works for our company now. And he's excellent. He's really, really good at what he does. And so with mirai, you would just load that. His way of specifying the number of cores is this daemons function, and then it just goes on and does its thing. Which of these two would I recommend? It depends on what day it is. Mirai has a lot of advantages because imagine you have 11 things you need to do and you have 10 cores on your machine, right? So with for each in future, what they would do is they would pre-distribute those tasks to what we call workers, like cores, okay? Or a worker could be a separate computer or something. But if I have 10 of them and I have 11 tasks, one of the workers gets 2 things to do. And let's say that's the last one that starts. Well, the first one might be finished with its one task, but it doesn't have a way of grabbing that extra one that the last one has to do. So it's not dynamic in that way, it's static. Everything gets sent out and scheduled at the very beginning. So Mirai actually has like a scheduler inside of it, like a queuing system. So if I have 11 things and one finishes, it looks around and is like, who's next? I'm done with all my stuff, send me the next thing, which has some advantages. I don't know that there's much difference from the user perspective between them speed-wise. I was running something today, and honestly, Future was twice as fast, and I can't explain that. But I've done the same thing with other calculations, and Mirai's been faster. So I think it just depends on what you're doing and how you're doing it. Mirai is also very much built to be, I think, very much user-driven in the sense that, like, we just released parallel per maps, and that's using Mirai. So I think it's mostly from I mean, the code is very elegant and well designed and things like that, but I think most of the use cases are for people directly doing things in parallel as opposed to maybe developers doing it. So anyway, the message here is you can't really use for each anymore. The new version of Tune will be 2.0, so everything from here on is like things you can do in 2.0. So you can't use for each anymore, but you can use Future Mirai, and that all works pretty well. All right, so I'll talk more about why this is important, but we came up with a different API for choosing tuning parameters. So like you can do a grid search, and you do all these different candidates for your model, like which has the best learning rate or number of trees or whatever. And then you do some selection method by saying like, oh, give me the one that has the best R squared or the lowest RMSE or whatever. So we have functions that do that. Show best is a good example of it. You can say, show me the model that has the best sensitivity, and show me the top model, like the first one. And then if I look at that, you know, we saw from the other graph that my sensitivity is highest when I have a really large class weight of 43, and its sensitivity is about 98%. But if I were to optimize on specificity, we want an even class weighting, and then you get almost 100% specificity. And similarly, remember with the Breyer score is sort of going the same direction. The most well-calibrated model has a class weight of 1. And so, you know, the problem is here, we have to choose one thing and try to optimize on it. And you could do a dplyr filter. You can be like, you can get these in columns and say, well, give me, you know, write in a range that has like the best prior score, but do a filter on specificity or something like that. You can absolutely do that if you want. But another option is use something called desirability functions. And a lot of my training in graduate school was based on like experimental design things that were being applied in medicine and in other areas. And desirability functions is something that came out of that. There's notes here if you want to read more about them. But what they are is it's like almost like a stupidly simple thing you can use to jointly optimize multiple things. So what you do is you take your like Breyer score, which let's say it goes from 0 to 0.25, and 0 is the best. What you do is you map that to a scale where 1 is the best value and 0 is the worst value, right? And if you want something that has to hit like an R squared of like 0.7 for whatever reason, you can make the area around 0.7 have a 1 desirability, and then things outside of that, you know, become less desirable. And so once you have desirability scores for the things you want to optimize, you take a geometric mean of them and then optimize the geometric mean. So visually what that looks like is, if I have sensitivity and I want to optimize it, and let's say 50% is the worst case scenario, everything less than 50% has a Y value of 0 because it's unacceptable. And then we just linearly say as sensitivity gets better, it's great, and then at the perfect value of 1, we top off at 1. And you can imagine that if we're trying to minimize something, it's sort of the other way around, where to the left we have very high desirability, and to the right we have low desirability. So if we were looking at that, let's say for the Breyer score, you know, if 0.25 is our worst value and we want to optimize 1, this red line here says, like, you know, our highest desirability should be around 0. Now these other two lines are things where you can make like a scale parameter, and that lets you modulate how important this particular thing is in the overall optimization. So if Breyer score is really, really important to you more than anything else, you can give it, let's say, a scale value of 2, and that bends the curve a little bit. So let's say we had a Breyer score of 0.1, if we had the regular linear effect, or let's see, I'm trying to eyeball that, but let's say our desirability is like 0.6. But now with the scale of 2, that's actually 0.3. So what you're saying is by increasing the scale, you're making the I want to say weight, but you're having the influence of that performance parameter have a higher computation in the overall geometric mean. Now let's say you want to optimize the Breuer score, but it's maybe not that important. You can make the weight less than 1, and then the opposite happens. It says, we're not so much worried about this. I can include this in the calculation, but I'm making it easier to satisfy the Breuer score desirability by bending it upwards like that. And then you might have something where you say like, well, anything between like 0.3 to point whatever is fine equally. So if you're looking at a range, let's say we want to say specificity is great as long as it's between 0.75 and 1. Everything below 0.75 would be 0, and it's 1 everywhere else. So there's a bunch of other desirability functions you can use. There's quite a lot of them. And if you want to do inline dplyr type stuff, which is what I wanted to do, you can use the desirability function to do that with inline stuff. One interesting note here is when you take the geometric mean, if any of your candidates or any of your parameters have 0 value, it's a completely unacceptable because you're multiplying by 0 basically. So some people put it like a little threshold instead of 0, they use like 0.01 or something like that. But it basically the rule is if anything's unacceptable, the whole thing is unacceptable, the whole combination. So what we might want to do is we might want to say, well, I want to maximize sensitivity, the green curve here, but I want specificity to be at least a certain value and also have it be well calibrated. So like we can say what that is, and then we have a function now called show best desirability, where you give it your tuning results, and then you say like minimize the Breuer score, the best value is 0, the worst value is 1 or 0.25. Just maximize sensitivity, and as long as specificity is between 0.7 and 1. And so then you can do that and get the top whatever most desirable outcomes, which here pretty much goes to a high desire or a high class weight. Now let's say we want more Breuer score, then I can increase that scale from the default of 1 to 2, and now we have a lower class weight and a lower Breuer score, but our sensitivity is still pretty good, but it took a little bit of a hit by doing that. So you can have these trade-offs between different things and just do a multi-parameter optimization is what it's called. There's a lot of different ways you can do this, and we're happy to add more, but there's a reason why we're doing this now, and that's related to the next topic, and I'll demonstrate why this is happening now instead of maybe when I could have done it a year or so ago. So that's new, and a lot of what we were doing, we've been talking about this since like 2017, and here we are in 2025, and it's happening now. We've had 2 things that we've planned on doing from the beginning, and they're literally both happening like right now, and we're really excited. Post-processing is basically, I talked about this at the conference a couple years ago in terms of calibration, is you do some pre-processor, you fit your model, and oh no, there's something still not quite right, but I like this model. Is there something we can do to bend the predictions to our will? Like you might have something that has like a really high R squared and you like it, but it's not on the 45-degree lines, so the root mean squared error is bad, and you don't want to change your model or don't know how to change your model. You can use a calibrator to fix that. Another thing you could do that we kind of talked about is you can adjust your class probability threshold for what you call an event and what you don't call an event. That's something you do after the model's done, and so on. So there's a variety of little things you can do here, and that's what post-processors are, and we're basically launching that in the next month or so. I'll also say that work that is outside of our group that we're collaborating with, there's just some people who have, actually from CMU, one's at Berkeley now, who have this thing called Delphi, which is like a disease monitoring platform, which is, like, more I talk to these people, I'm like, oh my God, this is so much more sophisticated than I thought it would be. But basically, they're big time series people who have to do a lot of ensemble modelings between other forecasts and their forecasts and so on. So they're really good at time series stuff. We're not. Like, we're not awful at it, but most of Tidymodels is not, we don't have as much stuff in there for time series as we do for other things, because the 4 of us don't really have a forte in that. Now there's all the model time packages that Matt Dancho runs with Tidymodels, and those sort of like capture this. But what Daniel and Ryan have been doing is they've sort of, without us knowing it, I mean, it's all on GitHub, but we didn't ever hear about it. They've been sort of shimming like workflows and some other things that had post-processors. So when we actually started doing, they're like, oh good, now we can give it all to you. And so they're doing pull requests, a little bit previously, but we're in the position now where they can start adding more pull requests to our stuff. So if you want to do any more sophisticated, like especially time series or quantile regression modeling, that's all being improved by them. So, all right, so that's what post-processing is. So we have this package that is the one I just sent before the Cran holiday called Tailor. And the idea is, like, naming is hard. We came up with Tailor because it's taking something that exists like a dress or a suit or something, and you're just making adjustments to it. And so a Tailor is sort of like a recipe. You're going to pipe in different things you want to do, but in a lot of ways, it's much more simpler. So if you want to, a recipe would be like step something. So we have adjust as the prefix, and then if it's a classification model, it's something like adjust probability. So if you want to have a logistic regression after the fact, recalibrate your probabilities. That's what I talked about, I think last year at the conference. You can have it do that. If you want to optimize the probability threshold, so your minority class is called an event more often, then you can do that with this. We even have tools that say, like I ran into this, I used to work in molecular diagnostics, and the FDA would always have you come up with what's called an equivocal zone. That if there's a zone, it's like, you think about like a class probability. If you tell somebody they have cancer based on some assay or some medical device, but the predicted probability is 51%, it's like, don't do that, right? So the idea behind an equivocal zone is you based on some data, come up with a region around sort of like the cutoff that you say, don't give them an answer. Tell them to retest the sample or redo the whatever it is. And so what we have is a way in a new vector type where it's kind of like a factor, but instead of labeling things as missing, we give them a label as equivocal. So they're not missing in the results, but they don't get counted when you do like RMSE or accuracy or whatnot, and so on. So these are the types of things you can do. A Tailor, when you run it here, it doesn't actually do anything. Just like initializes an object and you just layer things in. Unlike recipe order matters, but we have safeguards in here that are more straightforward. So if you want to adjust a class probability threshold, you can't do that before you recalibrate, because once you recalibrate, your probabilities are different, so that threshold you just made doesn't really make sense anymore necessarily. So if you did these out of order, it would kind of stop you and say like, no, you have to do it in this order. So some things about this are simple. For example, you don't even have to tell it what data you have at any point here. It's only when you get the fit to Tailor for some definition of fit that you actually have to tell it where the prediction columns are and so on. So this is a way to specify post-processors. And then when you want to use them, you, lo and behold, can just add them in the third slot of your workflow. So you can include a preprocessor, a model, and now you can include a third thing, which is a Tailor object or a different object that the Delphi people will make. So going with our class prediction problem we had before, I want to fit a similar neural network with most of the main parameters being the same, but I got rid of the class weights here. So I'm just going to fit a normal old neural network here, no tuning parameters in it. We're taking one-to-one class weights like we normally would. And then what we're going to do is, instead of trying to bend the predicted probabilities to be higher for the first class, we're going to leave them as is, hopefully well calibrated, and adjust the probability threshold to call something an event or not event. So really the tuning parameter here is in the post-processor and not anywhere else. And just in case it's not clear though, if you have tuning parameters in your recipe and in your model and in your post-processor, you can optimize those all at once just like you would do anything else. So this works pretty much like it did before. So yeah, so let's think about like what it means to be like the minority class here, that we want to increase sensitivity, which is associated with, in this case, the minority class. And if I have low probability estimates that I know are class 1, but they're not being called that way with a 50% cutoff, like the default cutoff, to make them more likely to be called an event, you have to lower the threshold from 50% down. You have to like lower the weight of evidence. So if you want more of class 1 being called class 1, you have to say like, oh, maybe if it's 10% or more probability, we'll call it class 1. But you don't know what that is. So what we're going to do is we're going to do a grid search where we look at values from like 1/100th to 0.5 along this grid. And again, there's 50 points here on the grid, but we're only fitting, this is the only tuning parameter, so we're doing tenfold cross-validation. We spend, and I mean a lot of time thinking about how this happens efficiently. We want to make sure if you're adjusting a probability in a tuning parameter grid, you don't ever accidentally refit the model when the model's the same. So we have, and I'm eventually going to write a long blog post about this, you have this whole scheme of like conditional operations. You go to tune a recipe and you get the first tuning parameter for your recipe, you fix that and then do the tuning parameters for all your models given that you're on that recipe step. And then we fix that now for each one of the models and then do the tuning parameter grid for the post-processor. So it's quite an optimization that we've figured out. And I know there's things we can do to make it faster, but there's the whole like idea of the sin of prematurely optimizing something. So it's not terribly slow right now, but I know we'll be making it a lot faster as time goes on. Anyway, the point here is you're only fitting 10 models instead of, was it 500 models before. The tuning parameters don't affect the actual preprocessor and model fits. But the code here is exactly the same. You're just giving it your grid, you're giving it your workflow, and it's just like anything else in Tidymodels. So wait a minute, what happened? Like I knew this was going to happen, but I thought somebody's like, dude, there's a bug in your code. Like as we modify the threshold, this is flat, but that makes sense. We're not actually changing the machine learning model at all. So the probabilities are exactly the same as they would ever be. And you can see the Brier score here is pretty low. It's about 0.04. So when you let the model be the model, it actually does a pretty good job of having a well-calibrated model. The tuning parameter here doesn't mess with the probability estimates. It just takes them and thresholds them at a different level. And this is relevant for the desirability functions, and I'll talk about that in a minute. Kappa increases with the threshold, and it tops out, I don't know, around like 0.4 maybe. But, you know, depending on your application, that might not be the best way to pick things. Again, you would maybe want to look at what your needs are from this model. Like, what should my sensitivity and specificity be, and then make this trade-off off of a plot like this or something else. So, so yeah. Any questions about that? So it occurred to me maybe like a year ago as we were doing this that having like a single thing you optimize sort of like prevents you from optimizing your probability threshold. Because if you want to optimize on sensitivity, then I guarantee you specificity is going to be 0, right? So you needed something in between to then pick tuning parameters. And that doesn't even touch the calibration aspect of it. If I had tuned all those other neural network parameters, you know, I want to factor those in, and those affect the model, but not the threshold. So we came up with this problem like, well, we need to have a way to jointly optimize things because post-processors don't really help you if you can't optimize them in multiple ways. So that's why the desirability function was a good solution, because what you can do is you can do trade-offs like we did before, where you can say like, hey, you know, calibration is important, minimize the Brier score with whatever level of the scale that you want, but now we can also independently adjust the threshold and the parameters that affect that separately in a way. So that's the main reason that the desirability function selection stuff happened now, because now we definitely have a need for doing it. So, so there you go. And I took the Brier score out of here because it doesn't affect the threshold. But if we had any other tuning parameters in here, I would put it back in. And then you can just play around with the desirability functions and figure out what your trade-off is and try different ways. You don't have to recompute the grid or anything like that. It's all after the fact. So, has anybody here ever used Jump, which is a SaaS product? I know. This is the first implementation I ever saw in desirability functions. And Jump is like point-and-click software. And it's quite nice, actually. That sounded really elitist when I said it's quite nice, actually. But it's really great. Like, I used to support a lot of lab scientists in their desirability functions. You know, I showed you like the sort of hockey stick curves that they give you. It allows you to click on them and just move them around in any way you want. And I just remember, like, when I was in diagnostics and we were doing experimental designs for assays, that they'd come up with something and be like, but what if I bent it a little bit more? And then they'd come up, they were constantly like tweaking these things. You can programmatically do that with R, but having a UI is both good and bad. But once they changed it, they couldn't easily go back to their original desirability function. So reproducibility is important. Okay, any questions about this? All right. So just a little bit about calibration. If you find this interesting, maybe go to the first link there. That's the video to the NYR conference. Boy, I have trouble talking about calibration because it seems like such a great idea, but please lower your expectations, and here's why. It's a really, really, really hard statistical problem because you think about, we know about overfitting, right? We know that like if you're doing like a machine learning, like a random forest model, and you repredict your training set and compute like R squared from that, it's wildly optimistic. In fact, if you don't get something very close to 1, you did something wrong, no matter how good your model is, right? So we know like reusing data for both like assessing the model and training the model is like a cardinal sin and will bite you because it has bit me before. And we're in a similar situation with calibration that if I take my, let's say, cross-validation predictions that I'm going to use, like my out-of-sample cross-validation predictions that I'm going to use to measure performance, I can't really use those to calibrate the model because now they're both like the judge and the juror, or the, I don't know what the right analogy is, but they're doing multiple things and they're not very good for calibration. So then we're stuck with this idea of like, well, where do we get data from? So we have a couple ways of doing it, and we'll be adding, I think, more capability here. The idea, especially if you're doing this in Tune, that let's say you do tenfold cross-validation. When you add a calibrator, what it does initially is it knows the calibrator's coming, so it leaves your your 10 folds alone when it comes to measuring performance. But what it does is it takes the 90% that the models build off and it shaves data off that to fit the calibrator. And it does that with the same sort of specification you use for resampling. So if you did 10-fold resampling, it shaves an additional 10% off the 90% that you have for modeling. Or, as in the other example, if you're doing time series resampling, that's very much like taking old data for your training set and taking the newest data for your assessment set where you measure performance, and then you just do windows, right? So if you have a calibrator with that, the default way we have it set up is it will take the older data that you use to fit the model and shave whatever the appropriate proportion is, like you had previously, from the data you originally specified for modeling. So it's basically reserving a little bit of data, or however much, whether it's a little or a lot, it's really up to whatever you're choosing to do. But proportionally, it's reserving as much data as you're using for assessment to fit the calibrator. And I should say that the only post-processor we have right now that requires estimation is calibration. If you're just optimizing the probability threshold or like putting numeric boundaries on your regression models, that's all fine. You tell us what that is and there's no estimation. But for calibration, you do have to use some extra data. Now, when I did this, when I was in drug discovery, what we had is we had basically kind of like a set of compounds that we would use. So I was doing like computational chemistry modeling, like somebody has a molecule they invent and they want to use machine learning models to predict, is it toxic, is it effective, is it soluble, is it like anything under the sun. And so we wanted to calibrate something, we had like a predefined set of compounds that were diverse enough to capture a lot of the design space we were in. And so we had like a static calibration set. And so what we can't do right now that we will, I think, do soon in Tidymodels is allow you to give a single calibration set that all the resampling and stuff will use when it goes to fit the calibrator. So if you have explicit samples you want to use, you don't want to shave any data off the training set, then you'll be able to do that. It's a little bit of a niche thing, and I think there are people in my group who are like, but we should resample them. Like, we should, unless it's sort of like a fixed thing that we all agree on. So there's more to do here with post-processing calibration, but I'm really, really happy with where it's at now in terms of all these tools that we have. So anyway, it gets complicated, and I'll be honest with you, I've only seen like maybe 2 or 3 examples, and I've tried a lot of them, where the calibrator really makes a difference. So it's really good if you have like a lot of data, like 1 million data points. And then in that case, you can see very small deviations from calibration, and then you can correct for them. But you need a lot of data to get a good calibration model. So it's there and it's useful, but it really depends on having a lot of data. So anyway, right. Any other questions? Yes.
Yeah, so does it like like if you have a validation and test set and training set, doesn't that take care of like
Well, so yeah, so the question is if you have a validation test and training set. So typically your validation set would be used kind of like we use cross-validation. So I like validation sets a lot because if I have a lot of data, I don't want to do 10 models. I have enough data reserved in one out of sample like validation set. But if that's going to be used to measure how performance is before I see my test set, then I can't use it for calibration. So like there's a book I have like links to here that I'm working on a new book, and the example that we have has a lot of data. So we actually, for that, do a 4-way split. We do a training set, a calibration set, a validation set, and a test set, because we have a ton of data. And in that particular example, if you go there, because there's links in here, you will see that there's one point around like 0.3 where there's just like a bump, where it's not really well calibrated in that area. And then adding a calibrator there just kind of gets rid of that little lack of calibration. So, yeah. It's a really good question. We had a lot of trouble naming the data set, so we decided to call it a calibration set, even if it's not actually calibration you're using it for. Like if you need to estimate something for a post-processor, what do you call that? And nobody's really gotten to the point, I think, with proper data usage in these tools. So I wrote a blog post, and just as I want to do, I was like, I don't know what the name should be, and I want people to recommend things. So I said, if nobody says anything, we're going to call it the potato set. Because my group has realized as I write test cases, if I need a string in a unit test, my default string is potato. So the running joke is there's potato all over the place in our repos in the unit tests. So I was like, why not? And so I think the hex sticker, Simon wanted to make it a big potato, but nobody would get that. So we'll see. Anyway, good question. Okay. We've also been talking about doing feature selection for a long time. And actually somebody, Steve Polly, wrote a pretty good feature selection recipe package called Clino. And that's been around for a while. It works really well. We talked about maybe extending it a little bit, and I don't know that he was really interested in doing that. So we'd always planned on doing more recipe steps. So that's what our summer intern is working on. And so what we decided to do is we decided to separate the tools that calculate variable importance type things like supervised feature selection statistics separate from the recipe package or the package that will have the recipe steps in it. Because what we want to be able to do is if people don't want to use recipes, we want them at least to be able to contribute to like a framework for doing this stuff. If they don't want to use Tidymodels, there's a lot of things in Tidymodels you can use without Tidymodels. We don't want to say you have to use our stuff to get like resampling or performance characteristics. So what she started is the filtro package. And that is, it's on CRAN, but I shouldn't say this on like a video, but when we have a new package, what we do is we sometimes send in like the minimal version with like one function in it, because it's easier to get that through CRAN. And then the second submission, since it doesn't have any reverse dependencies, it just goes through the automated system. So we put like 50 functions in this. No, we don't do this, I swear. So the CRAN version before their hiatus is the bare bones version of it.
Ripley watches this every month, you know?
Well, I have some things to say if that's true. So anyway, so filtro will contain like the underlying scoring functions and then the aforementioned important package. I mean, how egotistical am I if I'm calling something the important package? So that's a question that answers itself. That'll have the recipe steps in it. So before we get there, filtro works. So does anybody use S7 classes or S7 methods? We were talking about how to do this, and Hadley convinced us to use S7. S7 is a different, yet another object-oriented programming tool in R. It's basically a rational extension of S3 methods, which are the things that most everything in R uses. I think there's like 5 different object-oriented programming tools in R, if not more. I liked using this a lot. There are some differences that you have to get used to, but this is a package that usually developers are going to be using. You're probably not going to be loading filtro and doing filtro stuff in it. We have like higher level APIs to do stuff. But what we've done is for all the statistical methods we'll have for measuring how important some predictor is related to the outcome, we have these objects they're not functions, they're just objects that have data about that scoring function. So they all start with score, underscore. And in this case, I just chose one at random. It's doing a random forest importance based on oblique random forest, which is a pretty cool technology. And so if you were to just print that out, I probably will make a print method for this eventually. What it does is it had things where it says, well, what kind of outcomes can you have? In this case, you can have numeric outcomes, you could have factors. It has similar slots that say, what kind of predictors can you have? It'll have things like, can you use case weights with this method, and so on. So this object basically contains all the information about this filter, like the label and so on. I'll come back to this for one of these that is particularly interesting. But when you want to use it, you actually just use the fit function. So I take that score object. So AOV p-value, what it does is it works for regression or classification. So if you have a classification model like we have with our class imbalance thing, we have a bunch of numeric predictors. What it'll do is for each predictor, it'll fit an ANOVA model where since the predictor is numeric, that will be the outcome of the ANOVA model, and however many classes you have in the outcome will be the categories. So it basically looks to say, is there a mean difference in your predictor across the different classes you have? And so you can either get the F statistic back or the p-value back for that. If you have a regression model where you have a numeric outcome and some categorical predictors, it'll just do an ANOVA for each one of them and give you a p-value back. So that's a good example. If I were to run this on my data set, I basically get p-values. I decided unilaterally to put them in log 10 format or negative log 10 format because that makes sense to me. I hate the idea of like saying like, but it's less than 0.0001. So I'd rather just do it on log scale and not have to worry about it so much. And so it'll compute that for each predictor. And so you can do that for a variety of different score methods. Here are the ones that we have on the initial release, but I know of at least 2 others I want to add in. There's like these analysis of variance methods, correlations. If you want to calculate the correlation between some numeric outcome and some numeric predictor, that's a good, just as well as anything else. Or C-curves, information gain ratios, and things like that. If you have all categorical data, you can do like association p-values using Fisher's exact test and so on. The cool thing about this, and this is where Colino wasn't able to do, is you can apply multiple filters to your data even if you can't compute them for all your predictors. So if you've ever seen the Ames housing data, just as an example, it's a data set where the outcome is sale price of houses in Ames, Iowa. And the predictors are all things about the house, like how many bedrooms, which is an integer, or the square footage of the lot size. But it also has things like, is there a pool, yes or no? Or what neighborhood's it in? So you have both numeric and categorical predictors. So if I run like a random forest variable importance, I'll get a score for every predictor because it can do that for any type of predictor. But if I run a correlation filter, it can only run the correlation for the numeric predictors, like the lot area or the year it was sold and things like that. So what happens if I merge those together, like with like an inner join or a full join, then you get a bunch of NAs for the correlation score because you can't calculate a correlation based on a numeric outcome and some categorical factor, right? So one thing we do in there is we have sort of implicit fallback values. It's not like really imputation, but we basically fill in those NAs with a value that will not kick them out just because you can't compute their value. So in this case with correlation, we would add a value of 1 in there because, not because they have great correlations, because we don't want them to get filtered out just because they don't have a value. So the cool thing about filtro and some of the recipe steps is you can, much like desirability functions, you can optimize on multiple different ways of scoring your predictors, which can be very helpful. So filtro with all these fit methods will let you do all that stuff. And then the important package will eventually, probably maybe at the end of the month, I'm hoping, because we're supposed to talk about this at PositConf. And this isn't even on Crayon yet, so wish me luck. So we'll have things like a ranking procedure. And ranking to me is you take all your predictors and you give them a rank. How important are they? And that might be a fractional rank if they're ties and so on. And then to me, ranking is like, give me the top 10 bests or the top 15 best or whatever. Okay, so it's you tell me how much, given that I've told you how to measure them. Filtering is something where I say, well, I have a logical statement, and in that logical statement can either keep one of them or keep all of them, It doesn't, we don't say up front how many that is. So for me, a difference between a rank is you tell it how many you want of the best. But a filter is, I don't know how many are going to come out of this, but I'm going to tell you what I want. And if it satisfies, 3 of them survive the filter or 10 of them do, then that's what it should be. So step rank prop would be the situation where in proportions, you tell it, give me the top, like 10% here, and then you can give it a specific method, like give me the, you can tune on this, but like if you say, give me just regular old random forest importance and only keep the top 10%, then step rank prop will do that. If you want to give it an integer instead of a proportion, we'll have the same thing that just has a different argument for the number. So you can do it that way. Now, if you want to do more than that, like we had before with desirability functions, you can say like, I want to maximize my random forest importance scores, and as long as, keep them as long as the correlation's above 0.5. And that's absolute correlation, not like plus or minus correlation. And then you can tune on that. So, so this is more of like a multi-parameter ranking, whereas this is going to be like a single scoring function. And honestly, I think most people are just going to choose random forest because that's the one everybody knows about. But if you need to do something more complicated, you can absolutely do that here. And then finally, the filter here would be where there's no real tuning here. You just give it a logical statement. And I should say in each one of these, we know how to do delayed evaluation. So you don't have to tell it any more than what it should measure here and here. It'll look at what your inputs are and say, oh, now we need to go to filtro and compute these things, right? So that's why I said in the last slide, we kind of have a controlled vocabulary. So as long as you include any of these names in these functions, it knows what to compute and how to rank them and how to score them. So these will be the things that, these are actually pretty easy to write. The filtro stuff's where all the hard work is, to be honest with you. We write, unfortunately, we write recipe stuffs constantly. So that's why there's so many of them. So this shouldn't be hard to do. Any thoughts on this? We'd love to hear more if people are like, but I do it this way. Like, we kind of want to know that. So if you don't want to say now, like, drop us a GitHub issue and let us know.
Tell me at the bar.
What's that?
Tell me at the bar.
Okay. Because everybody remembers everything that happens at a bar. Yeah. Well, anyway, I'll shut up now. Something else, the original idea behind the important package was to compute variable importance. So it does that too. You might be asking yourself, like, why would you do that? There's Daleks, there's the VIP package, there's probably like Ranger, there's plenty of ways to do this in R. The problem is none of them do exactly what we want. And honestly, writing these importance scoring methods is really not hard to do. It's a pretty simple algorithm. But the reason that we wrote our function is 3 reasons. That we figured out the optimal way to parallel process all these things. So with these importance scores, what you have to do is you have to have a loop that goes through all of your predictors and one at a time basically shuffles them and computes the loss of performance when you make them nonsense. That's what the variable random forest importance score means. But you might get a bad shuffle, so you have to do that a lot of times to make the variance go down. So if you do it 500 times, you have 500 predictors, you have a 500 by 500 loop. And so we basically just squash that loop and we parallel process the bejeebies out of it. So it's very efficient in that perspective. Honestly, if the Daleks people had, and I've asked them like to do parallel processing, then we never would have thought about doing this. And the VIP package is really good, but it doesn't have some of the other features that we want. The second reason is, most of the time we have a lot of different performance metrics in Yardstick. So not only, like Daleks doesn't do multi-class metrics, at least it didn't last time I looked. So we want to be able to do that, or if you're not sure what metric, just do them all, right? We can just do that. So we're loosening up some constraints as opposed to some of the Dalek stuff. And the other thing that the other packages can do a little bit at our behest is to think more about what we want our importance to be. So let's say we have a model and we calculate its importance and it says, yeah, Tuesday is really important. The day of the week is important. Like we have some public transportation modeling data that we use for trains in the city of Chicago. And the most important predictor is whether it's the weekend or not. right? So the question is, do you want to know if day of the week is important, or do you want to know if Saturday and Sunday is important? And that may matter a lot. So if I have like a PCA thing I'm doing to get rid of collinearity, I don't really care if PCA number 4 is important. Like, I don't know what that is. I mean, I could figure it out, but I want to be able to say, I want the importance perhaps at the original predictor level before PCA, or I might also want to know which components are important. You know what I mean? So like if I'm thinking about removing things from my model, if I can remove the indicator for Tuesday, I still need the original variable. So it doesn't really, I mean, from a computing standpoint, it doesn't really change much besides performance a little bit. So what we've done is you can specify either way whether you want the original predictor or any derived predictors. And so this affects things if you have like dummy variables in your model. If you're doing splines, you probably don't care if the 17th spline term is super important. You're like, whatever. I want to know if lot area is important or whatever it is you're modeling. And so it lets you choose the level that you want to do your importance scores at. So that's kind of nice. We helped the people in Daleks and other people do this, but it's a lot more. It's not the same as adding an option with those features or with those frameworks. So it's a little bit easier to use, and I believe it's much faster to use it this way. Okay, I swear I'm winding down. This is like, okay. Only 2 more hours, yeah. Quantile regression, if you're a quantile regression fan. We made some modifications earlier in the year, I think it was this year, for parsnip and hardhat to have yet another model mode. So you can do regression classification, you can use censored regression for survival analysis, and now we're adding quantile regression. And so the only, I think, engine we have for that right now, which is a test with, is quantreg, which is important. And if you've never seen or heard about quantile regression, it's basically models that have, where you want to make your predictions at some quantile of the predictive distribution. So if I do a quantile regression with the 0.5 quantile, I'm predicting the median, not the mean value of my regression model. But you might also want to know like what the extremes are. So you might do the 50th percentile, maybe the 90th and the 10th percentile, and so on. And if you're a big fan of conformal inference and stuff like that, like they form prediction. They have ways of forming prediction intervals using quantile regression. So it can also give you a sense of like variation in your predictions. So so the way this mostly works is a long time ago, maybe like 30 years ago. That seems a long time to me. That probably later or earlier than that, somebody figured out a different objective function to optimize. So if you're instead of doing like sums of squared error, there's a special quantile regression metric or objective function you can use to fit your models, and that's what quantreg does. And so, so when you fit these models, some of them, the way the models work, it depends. Like some of them, you can tell it after you fit the model what quantiles you want to make predictions at. But most of them, you have to say up front which quantiles you want to make predictions on. So if you're looking at something like XGBoost or a couple of the other packages, they can do quantile regression, but you have to fit a separate model for each quantile. So like that's kind of tough if you want to do more than one, especially if you're using Tidymodels or some framework. So our engines that we haven't yet to write, that the Delphi people have probably written already, have wrappers to just do that. But the point is you need to know what quantiles you want to predict at before you get started. So the way we've done this is when you tell it you want to use quantile regression by setting the mode of your model, then we basically talk about what level, quantile levels you want. We spent so much time not arguing, it was a great discussion about how you give it the percentages of the distribution you want. They're not actually the quantiles, they're not quite levels, because levels is a very generic term, so we set it on quantile levels. So then you can just fit that and you get a quantreg model back. If you want to measure how well it does, there's some very, I mean, to me, there's really arcane, but there's different metrics that measure the quality of how well quantiles capture their distribution. And so those are being implemented for yardsticks. So once we have that, then we'll do the process of integrating all this back into like Tune and everything else. It all just will work for you. So that'll probably be, I'm hoping maybe Q1 or Q2 of next year, we'll have quantile regression all over the place. The one interesting thing is, like we had this mantra in Tidymodels that if I run predict on something and I have 10 data points in my data set I'm predicting, you give me 10 rows out, and I don't care what you have to do that. If you have this many go in, that many come out. So if you have missing data, you don't get n minus 1 of them, you get n of them. We pad the predictions and so on. But we have things like with survival analysis, when you're making survival probabilities, you might want to predict like a patient and their survival rate at 5, 10, 15 years or something like that. So you might want to make multiple predictions on a single row. And so we handle that using list columns and survival analysis. And the same thing happens here. If I want to make a prediction on a new data point, I might have like 50 or 3 or 7 quantiles. So what we did instead of using a embedded tibble was we came up with a new vectors format that this has as many predictions built into it. Like in this case, I fit a model with 3 quantiles, like 0.25, 0.5, and 0.75. So when it prints out, they're all in here, but when it prints out in this tibble, you get the median one, or the one closest to the median. And then if you were to sort of bundle it using as tibble, you can see that I get, how do I highlight this well? Oh shoot, don't do that. When I unbundle it, you have as many rows for each input row as you have quantiles. Here we go. So for example, you see row 1 is here 3 times, and you have a column for the quantile level. So we don't do this automatically because it's hard to do a merge, because if you merge this on your training set, now your training set has 3 times as many rows as what you started with, and you have to keep track of that. So the reason why we do embedded tibbles or like a new vector type is so that you can keep an n of 1 being an n of 1, even if you're making multiple predictions on the n of 1. So we'll have a little bit better APIs for this coming up, but if you're a fan of quantile regression, we'll have a lot for you next year. Okay, this is a fun one, sparse data. Sparse data is a situation where you have a column of data, no matter how big it is, and it only has a few distinct values. And so let's say it's like, I used to have this problem in chemistry all the time where they count like the number of fluorines in a molecule, right? And we have like 1 billion molecules in our database, and they're mostly 0. So you have like 90% of them at least are 0, and then maybe another like 8% of them are 1s, and then some weird compound has like a 15. That's sparse data. You have to treat it like it's a number, but like a factor in R. It only has so many values, and if you could store it, just knowing how many values there are and where they occur, that's a sparse format. So a lot of times with like bag of word models and text in a lot of other places, you have a lot of binary data or low count data that you have to store in a very inefficient format because sparse tools like sparse data formats aren't, we've always had that in R for like a long, long time, but we don't have many ways to process that data, because if you go to compute like PCA on that data set, which is something that makes sense, you have to convert it to a dense format, which then explodes your memory, right? So it's a thing where like we've had a lot of instances where like there's a sparse matrix format in R and it works pretty well, but again, like if you have your Ames housing data set, how do you deal with neighborhood? Do you convert that to like integers, but they're not really integers? Like how do you do that if you have mixed types of data? So we've been grasping with this for a long time, and we finally solved it. This is mostly Emil's work. In fact, it's almost entirely Emil's work. We had this concept of what we thought of as like a sparse tibble or a sparse vector instead of a sparse matrix, because tidyverse stuff is all built on the ideas of data frames. At first we thought, well, what if we came up with a data structure that took like a sparse matrix and let you do a filter and a select and stuff on that? That seemed like a good idea, but then we had the problem of like, well, what do we do with categorical data? So then we were like, well, we're not going to do that. So we came up with this idea of like a sparse vector. It could be a numeric vector or a non-numeric vector. But what we can do, and we have some rules for this that work pretty well, is we can kind of silently convert your data in certain instances to a sparse format, each individual column of your data frame. And then they look like any other vector in your data frame, but they're actually stored in a sparse data format under the hood until you need them to not be sparse anymore, in which case it deals with it the way it deals with it. And so in essence, we have like sparse tibbles now, whether you use them in Tidymodels or not. If you have like, it's a tiny little bit overhead versus a sparse matrix, but that little bit of overhead gives you factors and other data like dates and things like that in your data frame. And it turns out that R has this thing, it's very arcane, called altrep, which stands for alternate representation of vectors or objects. And altrep is very, I'm not going to do it justice. It's been around in R longer than you would think it has been around. So it's been working for a long time. We know it works, but what you can do at like the C++ level is you can trigger, let me give you an example. Imagine you were just in R and you start a fresh R session and you say x equals 1:e to the 38. Like an incredibly long integer vector, right? That's going to take one little statement, if R didn't do anything special, would take up like an inordinate amount of memory on your machine, maybe more than you have. Okay, so what R has decided to do is to say like, okay, we know what that is. We know we shouldn't actually do that. Like, don't do that until you need to do that. So, but the cool thing it does is it says, it knows, for example, oh, that's sorted. So if you go to say sort on that, it knows it's already sorted, so it doesn't do anything else. So it has a bunch of rules where it says, oh, here's a place where we could not actually do the thing you asked me to do, prolong it until you actually need it, and even if you want to do something to it, you may not actually have to do anything to it at all, right? So it's a bunch of like really arcane rules in R, and it's been this way since, I think it was like 2016 that I knew that this was in there, and it was considered experimental by base R at the time, which I was like, well, why is it in R if it's experimental? But it works really well. So anyway, we use alt-rep to basically say, okay, we know this integer vector, this really large integer vector you had, looks like an integer vector and smells like an integer vector, but inside of recipes especially, we're not going to treat it like an integer vector. We're going to treat it using alt-rep and actually store it in a separate sparse format that we know how to do things with. We know how to count it, do the mean, the median, the variance, and basic operations on it. But there are certain things like if you do, I don't know, like the kurtosis or something of that vector, it's going to convert it into a dense format and do that. So anyway, if you're making dummy variables in recipes like step dummy, you're using alt-rep and sparse vectors, whether you realize it or not. So we know there are places where this will especially shine inside a recipe. So you can use that as its own thing using the sparse vectors package. But a recipe is designed to do processing of your data before you give it to the model, okay? And so inside a recipe, there are things that we can do to save you, temporarily, save you like a lot of memory. And then you might you might end up having data that doesn't need it in that large memory format. So for example, if you're fitting an XGBoost model, you automatically have to convert your data to a sparse format just to use XGBoost anyway. So what we do is we say, well, let's not do that. We know how to convert really fast from our sparse format to XGBoost or glimnets or rangers or LightGBM, right? So these are 4 models you can do this with. So you actually never have to have that massive data matrix. We can keep it really small, and then we can give it to the packages that know how to make it into their sort of like small format. You can opt out of this. So there's an argument that you can say, don't do that. And so it's not like you have to do this. Emil gave a longer presentation about this recently, and here's some screenshots from that. There's a link to it in a minute. So if you really are interested in it, he goes through a lot of details. But he just took something that maybe we've all thought about doing, is taking the NC Flights 2013 data set. Now, some features that are in that model are the airport. So there's a fair amount of airports. It's also a large data set. Does anybody know off the top of their head? It's maybe like 500,000 data points or something. I don't know, it's probably smaller at this, but the data set's large. And also the tail numbers of the aircraft, like each individual aircraft has a factor variable. So you're gonna make dummy variables of that, you have many rows, you have many factor levels, and you end up getting like maybe thousands, or not maybe, you end up getting thousands of dummy variables, which by default get stored as integers. And so if you did this before and ran an XGBoost model, like the one down here, it would take a couple minutes, and you're looking at 82 gigabytes it needs to do that, right? That's just to convert dummy variables. Right now some of you would be like, well, don't do that, and that's the best answer. But the point of this exercise is nobody looking at that code would say, oh no, 82 gigabytes, right? All I'm doing is like I'm computing dummy variables and like doing some imputation, like what? Like, so you wouldn't know that happens. And so he had a previous version that took a little bit longer, but when he ran it before the meetup he was just at, it took him 4 seconds to do everything on that page, or the model and the recipe. And instead of 82 gigabytes, we're looking at 822 megabytes. So when this happens, it's an incredibly like wonderful, amazing thing, and it's like magic. If you're interested, we actually ran simulations where we simulated all sorts of types of data and sizes of data and looked at the memory utilization with and without sparsity, in the execution time with and without sparsity, and then fit a bunch of machine learning models to get a good prediction equation that would make the right choice. Like we came up with a scenario that says, here's when this is a good idea, when you don't use more than an extra, like, I don't know, like 10 megabytes of data of memory or something like that. And if you're not slower with sparsity, we wrote a bunch of machine learning models. It ended up being, I think, a Mars model that would make predictions when you have your data, when it should convert it to a sparse format and when it shouldn't. So it doesn't automatically always do it. If you have like 2 rows, it's like there's no point of doing that. It doesn't really slow you down that much, but you shouldn't do it if you don't have to. So we have some rules in here to figure out when and how you should do this. But this is quite amazing to me. And we've been thinking about this and trying to do it for a long time, and it wasn't until we got the alt-rep sort of connection that this happened. So it's pretty cool. We've written a lot about it because it's kind of confusing, because you might be like, how's that possible? And it's a little bit arcane, but there's a lot written on this, especially by Emil. Catboost. Catboost is a very popular boosting method. It's in software engineering ways, it's similar to XGBoost, by which I will apologize up front to any catboost people watching this. Where XGBoost, it's a compromise that shouldn't be made, because they have like one GitHub repo to do like R and Python and C and stuff like that, and it's the interface isn't great, and to install these things from sources it's like takes heroic efforts, to be honest with you. And I think they tried repeatedly to get catboost on CRAN, and I think it's because CRAN's uptight and it's C++ stuff, and I think maybe being more Python people, they were like, we're done with this. So I'm pretty sure it's never going to get to CRAN. And normally we would be like, well, it doesn't have to be on CRAN for us to use it, but if I can't install it on my machine to test with, like it's gotten better in the last year in terms of installing it from scratch. I was like, I'm not even going to bother with this, because it takes me forever to install it if I can install it. But now I have code to install it that works. So in the latest release of Bonsai, we have a catboost engine, and it works pretty well. The thing I figured out the first time it ran, which we should probably change this, is it writes out a lot of files to your directories. So whatever directory you're in when you run this is going to get spammed. And I thought, well, that's not a good default. So I'm going to change this soon. But after the first time I did this, I realized there's an option in catboost that tells it what directory to put stuff in, and it's just going to temp. So it works. And it's good because Emil and I are both writing books. We're going to talk about this, so it's nice that we can actually run it in R. But otherwise, I'm at my wit's end, because everybody's always like, catboost, catboost, catboost. I'm like, oh my God. So it's there, and I'm happy about that. It may not sound that way, but I actually am. Yeah, so that's the thing. And then AI tools. I was going to demo something, but we probably don't have time, and this isn't my laptop. So if you, okay. So Simon, as I mentioned, has been in our group, and he's been doing great work, but he's been making amazing AI sort of support packages. We do a lot of like preventive maintenance in Tidymodels, and I can't describe to you how many man hours, if not man days, this has saved us. Like, he has a package called Chores, for example, where you can just write a very, very simple prompt, put it in a gist, and then you have an RStudio or a positron key combination you can use to execute it. So like, we're converting all of our old R like warning and error functions to the really nice ones in the CLI package. And they're everywhere. And then we have test cases for them. And it's like, it's an enormous undertaking for all these packages. And so he made a chore for this. And I think it took us like maybe a week to do all this. So like, we just highlight code, Control P, C. I have to do it in my head, and then it it does a great job of just converting all the old syntax to new syntax. If you want to convert old book down or markdown stuff to Quarto, this is what you want. You want to use a chore for that. So whether it's that or like the NCP tools or not RAG so much, but he's been just on a roll making these assistive, both front-end things that users will use and all back-end things that that developers will use. One thing that's relevant for Tidymodels is, so we think about like a prompt. Has anybody used Databot or tried it or heard of it? It's a thing that we've been working on. We don't talk about it a lot, but it's like an interactive like data assistant where you can say like, hey, take the data frame here and tell me what I should put in a scatter plot, and it'll make recommendations for you. So it's some data analysis and visualization stuff. But the thing is, like a tool like that is only really good for things that are like a dplyr or like a ggplot that happen instantaneously. And that's not Tidymodels unless you're like doing empty car stuff, right? So let's say I had like a 10 gigabyte data set, and how would I use an AI tool with that? And so he wrote something called Predictive, which is like a shiny bot, and it is somewhat asynchronous. So you can load a data set, and I tested it a while. It did really, really, really well on some things, kind of like, oh shit, well, as somebody who's a developer, I'm like, oh no. But then it just fell flat on its face and it's not like a problem with predictive, it's a problem with AI when you ask to do anything with any modeling nuance at all. Like it was, and I was like, wait, why did you do that? And it would go on this like, I'm such an idiot. I can't believe I did that. And it would be right after you'd say like, well, how do I fit a model of this? And it would like repredict the test set immediately. And I'm like, but why did you predict the test set? But when it predicted the test set, and it came out with like stars and like a fancy table, like the XGBoost model did great. You have a fantastic model that you can build. And then you're like, but why did you just predict the test set twice with different models? Like, oh my God, I'm such an idiot. And it's like, and you're like, oh my God, like I hurt this thing's feelings. And then it did something else wrong. And I was like, but shouldn't you do it this way? And he's like, that's the second huge mistake I made. So it's just like, I'm like, well, if you know that that's a mistake, right? So like, it's like this chicken and egg thing. Like, if you knew that, why did you do it? So anyway, I would demo Predictive. It worked really well. Like if you're doing like exploratory data analysis and stuff like that, it actually did some things. Like I was like, oh, tell me what predictors are important in the outcome in here. And it did some stuff I never would have thought about doing. I was like, oh, that's not a bad idea, actually. So it's something it's really good at and something it's not. But the interesting thing, and the reason I mentioned it is the asynchronous part, where it can say like, hey, let's try an XGBoost model, logistic regression, and like k-nearest neighbors. And then it does that. It launches them, and it sits and it's like, how you doing? And it waits. It's like, hey, things are great. And then as soon as it gets results back, it's like, hey, your XGBoost model had this performance. So it's like, the reason I think he maybe developed this is we're going to be dealing with things that aren't immediately instant feedback that you get. So this was a good framework for if I do something that takes like a couple of minutes to run, how do I stop my AI from being like, okay, later, dude, or like timing out or just not knowing what to do when things come back. Like instead of you having a prompt that just sits there doing nothing. So give it a try. Realize that it's like a test thing and it's kind of interesting. But I found it actually quite nice to use. So that's examples of things he's doing and will be doing. And it's an interesting problem. The talk I'm giving at the New York Art Conference is, he wrote a package. There's this thing that our founder helped write called Inspect, which was a UK initiative, like governmental initiative, and our founder just like moved to England for a couple of years and just worked on this Python thing for like, how do you evaluate an AI model? Like if you have a way of saying like, this is whatever % correct, like how do I take that? Like both from a software engineering perspective and from an analysis perspective, how do I like benchmark it in terms of performance, right? And so Simon wrote sort of a wrapper around some of that, but a simpler way for R. So like you can write things that are like kind of like unit tests for your AI thing. So if you have an AI prompt that's writing ggplot code, and you say, hey, how do I do a scatter plot? It should have geopoint in there, right, with the right variables. So just as a test, like he wrote that, and then like you can do it multiple times if it's stochastic, and you can measure its reproducibility and all this stuff. So 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 Confluence actually had an interesting white paper on this about a year or so ago, and it said all the right things. Like strategy-wise, it's like, hey, we need to do variability and think about hypothesis testing and statistical analysis, right? Like controlled randomized things. But then it showed its equations, and it was like, oh God. So it's not the best analysis tools there. So the thing I'll be talking at the conference is like basic statistical methods for evaluating models, for evaluating how well AI models work, assuming you have substrate to say, here's where it did well and here's where it didn't. That's the problem, is if you have like 15 unit tests and you run it on 5 different models, like 3 times each, now you have to maybe go through and rate each one of them. And that's the holdup. And we can't, I don't know how to solve that. But once you get that information, we have methods to say, yeah, this is statistically better or worse than that one, kind of thing. Anyway. And then almost last thing is, Tomasz wrote this fantastic thing. I love Quarto, and I shouldn't speak for other people in the company, I'll speak for myself, that I hate its documentation. Because I'm always trying to figure out, like, wait, how do I cross-reference this? I can never find things in the documentation. So Tomasz wrote this package called Ragnar, which you give it links to help documents or any other materials you want, and it ingests those into a RAG format and does a really, really good job of capturing as much documentation about something as you want. So if you want to make a chatbot or something related to those things, for me, I feel like, for what I'm about to tell you about, for Quarto and for Tidymodels, when I did this, it made a drastic improvement on the quality of the answers you get. So I wanted to make like a help function, basically, for Tidymodels. We have so much documentation, so much written about the syntax and why we do things. It took me maybe like 5 minutes to write down some URLs, turn it loose. It generated like an 800 megabyte, basically DuckDB library of all our documentation. And then you can hook that into like a Shiny chat, and then the quality of my answers went way better. Like it would hallucinate weird recipe steps. It would do all kinds of crazy things. But knowing what the answers are, I'm stating the obvious, but knowing what the answers are made an incredibly, it's interesting. The code that it gave back was nearly perfect. But remember, I gave it all links to all the help. And I would say maybe 75% of the time, and I can't explain this, when it said see more at, it would completely make up a link. And I'm like, that's the one thing I gave you. Like that's literally, I gave you the links, and they were making up different URLs for them and saying, check it out here. And at one point I measured them and I'm like, it's about 75% wrong. So the code is really good, but the links was a nightmare. So anyway, so I haven't finished this yet, but if you want to look up under Topepo TM help, I think that'll hopefully be a thing soon. I thought I might use it for our conf, but I don't think it's going to be ready in time. Okay, that's AI tooling, really shameless promotion. So I'm writing another book. It's about 40% done. It has a Tidymodels companion to it. Maybe when we get a Python person in, I intend to write, or partially write with somebody else, like a Python companion. There's no real code in here, but we have like the website. Oh, didn't mean to do that. The cool thing about it is when you read a section on calibration, at the end of it, there's little icons. Right now, there's only Tidymodels, but there'll be like a Python icon where you click on that, and it'll take you to the relevant Python computing page that has, okay, here's how you do all this stuff. Here's all the different Python packages that do it. Here's an example. So we're kind of like rewriting Applied Predictive Modeling, but better, and taking the code out and putting it in separate formats. And this is all on all the materials on the website. All the stuff in Tidymodels we've done has made our book a little bit out of date, so I'll have to update the website, but hopefully we'll get a new print version or a second edition out of that. And then Emil has been writing a feature engineering encyclopedia, and I mean seriously like an encyclopedia. He's planned maybe 200 entries. So if there's anything you want to know about data that before it goes in the model, he's diving in like way deeper than we did in our feature engineering book. And he has both R and Python code there. So he's still working on that. So there's that. And then finally, I mentioned quantile regression is something we'll be working on. Some little things that I got like 80% of the way done, but never got over the finish line in the last year is parameter constraints. So you might want to say I'm trying to think of the examples I have of this are somewhat arcane. but you might have like a grid that you want to process, but like, oh, here's a good example. Let's say you're doing random forest in PCA. Maybe that's what you want to do. But random forest has a tuning parameter for mtry, which is how many columns it should sample when it goes to do splits. And then PCA has a tuning parameter for the number of components. So if I have a model that says random forest should use 20 predictors, but I only use 4 PCA components, so that doesn't make any sense, right? So we have a tool that will allow you, when you're either making a grid by yourself or when, let's say, TuneBayes or something like that is looking at new candidates, to you write a parameter constraint like a logical statement, and it will just never use those instead of failing or just giving you redundant results. We also, the Gaussian process package we use for Bayesian optimization is on its way out. It almost got pulled off of CRAN, and the fantastic statistician who wrote BART and a bunch of other stuff, he contacted me because we use it, and he's like, I'm just gonna let this thing die. And I'm like, can you keep it going for a little bit more? And there's a newer one that we like a lot that's a lot more efficient, so we'll be transitioning over that. And then I have a nested resampling tool, which maybe nobody cares about, but we'll probably work on that. We've had a lot of questions about causal inference, and that gets really highly rated on our surveys we do for users. And Malcolm Barrett and Lucy McGowan have been writing a book. And so I think we might link up with them a little bit more than we normally do and see. We've already gotten some causal stuff sort of on board, but not merged. So maybe if you're a causal inference fan, like, put in an issue and help us push that. And then apart from that, I mean, there's more stuff to do with Tidymodels, but I suspect, does anybody know what I mean by our snow leopard release? Okay, yeah. So people of my age remember Mac OS 10.4 or something like that. Is like this is when Macs were becoming like sort of like the powerhouse of quality that they are. And they wrote they were naming after big cats. So they had like leopard, but they put so many new things in there that it was kind of a little bit dodgy. The quality of, like, the results were good, but like there were errors and things like that. So the next release is called Snow Leopard. And they were like, look, there's no new features in this release. We're just going back and fixing stuff and making it faster, and making it easier to use. And I think after all the stuff we've done with tune and sparsity and everything like that, we need a Snow Leopard phase of a few months to go through and just like clean everything out. There's some technical debt and some other things. So there'll be a little bit of like, not a hiatus of things, but I think our development has been at its all-time high in the last year, but it's gonna sink down a little bit in the first half of next year probably. Anyway. Lastly, the problem that we have is all our packages depend on each other, right? So it's hard for us to talk about something like sparsity until it's there everywhere. So we'll release things and not talk about them. So there's a period where like we in some, well, definitely the Tidyverse now, we just don't have anything new to talk about, even though we're really, really working hard. And so, so for us, it seems like it's like nothing and then everything and then nothing. We don't want people to worry about, is it still happening or are you still working on this? We are. We were actually kind of concerned because most of the Tidyverse people were working on positron for a while before anybody knew positron was a thing. And we were kind of worried people were going to be like, what's happening? Why isn't Jenny committing anything to use this? Or what's going on with dplyr? It hasn't been a commit in a while. And luckily, nobody picked up on that. But we're still working on Tidymodels in some ways, but they might not be obvious ways. Anyway, thank you for sitting through all this. Especially thank you to our team and our intern and all the people that have helped us in the past and been on the team. So, thanks.
So let's ask 5 minutes of questions from our resident superhero here to ask whatever you want, and then we will go to the bar where you can ask more questions. So you switch spots with me, get back over here.
If I haven't put you to sleep already, now.
Who has any questions? If not, there's a few virtual questions.
Yes.
There was talk towards the end about how you make things faster. What would you consider an acceptable or an unacceptable benchmark for these in prod, given a fixed data size?
That's a great question. It depends on what it is. Like Simon wrote a great, in fact, I have it bookmarked, a great post a while back. When we were initially considering causal models, it's an interesting problem where you're fitting very quick models, but many of them, kind of like a bootstrap or something like that. And so he found that there were very small changes that we could make that seem innocuous when you benchmark them, they're like a fraction of a second or less than a fraction of a second, but when you aggregate them, made a big change. So I don't know, it's hard for us to say. We thought about for a long time ways of measuring when our code gets slower without us knowing it. Like using Tidymodels unnest versus vectors vec chop. I can't remember the name of it, slice or whatever it is. There's a huge difference in performance in doing that. And unnest does a lot more. But for like basic stuff we do in packages, we found that using vectors, for example, is incredibly fast. So sometimes we just, like here, another example is like with pre-allocating a data set is really good. Like if you know you have 1,000 things you need to stuff into a data frame, but they come in chunks of 100, traditionally just R-binding things together is really slow. And that's because of how it uses memory. It turns out that the dplyr functions that do that don't have that problem. So when we were refactoring Tune, I wrote like a reservoir that we would fill up with predictions, and it turns out that did nothing when we were using dplyr like bind rows. So it's hard to say because we found things like using just like writing tibble as opposed to bare tibble in the long term makes a big deal, even though it's like a minor thing. It's very hard to say. And we don't even have ways besides like the bench package to measure like, the thing is what's frustrating sometimes is people, like somebody was trying to write the data.table versions of all our packages, thinking like, we'll speed it up. The problem is not like dplyr or anything that's not data.table. If my XGBoost model takes 6 minutes, me shaving off 20 seconds at best or 10 seconds off of like data table versus dplyr doesn't matter, right? So all the inefficiency, not all of it, the vast majority of the inefficiency for any moderately sized data set is all in the hard computing that happens in the machine learning stuff. So it's not like we think like, oh, it doesn't matter, but at the same time, we look at things relative to that sometimes.
Virtual question, I'm not mic'd right now, so if you could repeat. Is Tailor replacing the probably package?
Is Tailor replacing the probably package? No. Probably is sort of like the engine of Tailor. So Davis, who used to work in our group, and Simon are very similar in that they want nice, clean packages that have very, like you look at them and it's a thing of beauty, right? The way their code works and naming, and it's also clean. It's because all the dirty work happens somewhere else, because modeling is dirty work. And so the probably package is the thing that handles all the dirty stuff, and then Tailor just calls it. So like Tailor will say like, hey, you should calibrate using logistic regression or like isotonic regression, and probably is like, okay, I'll do that. So like you can think of Tailor as like the boss, and probably is like the person who actually does all the work. So that comes off maybe not sounding great, but it's kind of true. Yeah.
Last one question in person. Let me just see.
Can I ask something?
Yeah.
Are you guys planning on getting an MCP for Tidymodels?
Are we planning on getting an MCP for Tidymodels? Somebody's already done that, and I think there's like I would search for like MCP Tidymodels. If not, I wouldn't be surprised. Okay, I'll try to keep this short. And I'm not an expert at this, but what I do know is the problem right now is we don't. One reason I haven't been disengaged with AI, but I kind of want to wait till they get their act together. In the sense of like, do I use RAG? Do I use MCP? Like there's all sorts of different ways that we can make AIs better, right? Like once we get the model, like the prompt matters a lot, and all these other. I talked about using RAG made a huge difference. So I'm not doing that work because I want them to just figure all that out, and then I can use it and make it better. I want to be on the cutting edge, not the bleeding edge, basically. So I know maybe the BTW by the way package will do that for you, I think, but I think somebody's already made that for Tidymodels. So yes, but I don't remember the link for it or the name. But I did see it on like our set's Twitter isn't a thing anymore, or if it is, I wouldn't go there. But Blue Sky's been pretty good, and I remember seeing it quite a bit on Blue Sky. And if it doesn't exist, maybe send us a note because Simon could probably do that in his sleep. Sorry, Simon, if you're watching.
Make it so, man. Tell him to make it so. Make it happen.
No, I'm not.
All right. So I think that's good for time. If you have more, I'm not Mike, but those are people at home. All right. If you have more questions, come to the bar and ask, or I'll give you out. Everyone who's watching virtually, Max's personal phone number is. No, I'm not gonna do it. You've done that before, though. He's given it out on Twitter by accident.
Long called me. He's like, dude. I'm like, I didn't know you had my number. He's like, hey, don't. You instead of DMing somebody, you actually
tweeted it. I think he tweeted his phone number.
Like, whoops. So now JD has my number, so that's good.
Which is a good thing.
Yeah.
If JD is watching, he needs to give a talk here soon. All right, so everyone, it's a big round of applause for Max and his really big suite of packages. White Oak Tavern, we're going to break down. We'll see you all there. Thank you, Max.